Trigonometry, Chapter 1, Trigonometric Functions, Section 1, Angles, Video 6, Standard Position Quadrantal Angles. This series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. In order to study trigonometry, we often need a systemic way to arrange objects. We will do this by placing angles on the Cartesian plane. In other words, the xy plane with the x-axis and the y-axis. And when we do this, we'll place them in what is called standard position. An angle in the Cartesian plane is in standard position if two things happen. Number one, its vertex is at the origin, so the corner of the angle is sitting at the ordered pair 0, 0, and its initial side is on the positive x-axis. So it'll look something like this. Oh, I'm sorry. An angle is said to lie in a quadrant if its terminal side lies in that quadrant. So for example, here's a picture of an angle in quadrant 1. Notice the vertex is at the origin, and the initial side is sitting on the positive x-axis. And if we rotate it in a positive direction and stop with the terminal side in quadrant 1, that's an angle in standard position whose terminal side is in quadrant 1. Theta denoting the angle's measure. If we keep rotating the terminal side, we can get to quadrant 2. Notice the initial side is still on the positive x-axis. That's where it always initiates from when it's in standard position. Keep rotating until we get to a terminal side in quadrant 3. It's quadrant 3 angle. And if we keep rotating and have the terminal side in quadrant 4, we get a rather large angle. Again, the initial side is always on the positive x-axis. Now, you may have noticed that all 4 angles illustrated previously had positive measure. That's because the terminal side rotated counterclockwise from the initial side. Rotating counterclockwise, and it continues rotating and rotating some more and rotating some more. These are all positive angles. Now, for any positive angle in standard position, with a measure of theta less than 360 degrees, so less than 1 complete revolution, we can determine what quadrant it lies in, the angle, or more specifically, its terminal side, based on its measure. Specifically, let's think about it. How far can you rotate and stay in quadrant 1? It's got to be more than 0, but less than what? What about quadrant 2? More than what, how many degrees, but less than how many? And 3 and also 4. Well, oops. In quadrant 1, your angle is between 0 and 90 degrees. So you start a rotation, but you don't quite hit a right angle. And once you pass 90 degrees, you go into quadrant 2 until you hit 180. So the next 90. And then once you pass 180, you're in quadrant 3 until you get to the next multiple of 90, which is 270. And then once you pass 270 degrees, 3/4 of a rotation, you've ventured into quadrant 4. Remember, we're only talking about angles less than 360 right now. We'll discuss negative angles and angles greater than 360 degrees in the next video. Now, you may notice that the intervals for determining the quadrant of an angle did not include 0, 90, 180, 270, or 360. Go back and look. All of these say less than. They don't say less than or equal to. Well, that's because each of the angles that has a terminal side, each of these angles had a terminal side that lies on an axis. Each of these angles, the ones listed here, have a terminal side that lies on an axis and not inside a quadrant. Angles whose terminal sides lie on an axis are called quadrantal angles. Quadrantal being the adjective form of the noun quadrant. For example, 0 degrees, no rotation, quadrantal angle. Its initial side is on the positive x-axis, but so is its terminal side. Next quadrantal angle is 90 degrees, 1/4 of a rotation. Terminal side is on the positive y-axis. Next quadrantal angle is 180 degrees, a half rotation. Remember, initial side's always on the positive x-axis. For 180 degrees, the terminal side is on the negative x-axis. Next quadrantal angle is 90 degrees more, 270 degrees, 3/4 of a rotation. Terminal side is on the negative y-axis. and then 360 degrees, one complete rotation, the terminal side is back on the positive x-axis. There are other quadrantal angles that we'll encounter as we examine negative angles in standard position, as well as angles greater than 360 degrees. That'll be in the next video. Now you try. Pause the video and try each problem. Determine which quadrant each angle lies in, or state that it is a quadrantal angle. Pause the video and give it a try. Spoiler alert, if you haven't paused the video, I'm about to show you the answers. This is your last chance to pause. And here are the answers.